Hey everybody, Mr. Judson here. So what we're going to do in the rest of this section, and it's going to take us a few days to get through this, is we're going to look at what we call the basic functions in math. A parabola, a line, a square root function, an absolute value function, the greatest integer function, which we talked about last time, things like that. And you know, every time I do this, it always reminds me of a conversation I had with the Dean of Math over at TCC one year. You know, we were kind of discussing different classes and preparation level and stuff like that. And one of the things he said is, well, you know, you really expect a pre-calculus student to have a general knowledge of the basic functions. Meaning I could write one down and you guys would go, oh yeah, I know what that looks like. And I could graph that if I had to. That's what we want to do here now, is we want to make sure we have that basic knowledge. I'm kind of disappointed in our book in this section because they sort of go, all right, here it is, you guys should know it, let's go. And chances are that's probably not where we're at. And so we're gonna spend a couple days in this section just making sure that we get all of the basic functions, all right? So the one that we want to start out with is the parabola. And most of us look at that and we think it's some kind of shape that would look like this. And I know that last year in our Algebra 3-4 book, they gave us this equation, y equals a times, in parentheses, I've got x minus h squared, minus or plus a k value, sorry, out here. And one of the things that I want us to realize is this a and h and k, these are just variables, okay? I could put any variable in there that I want. Doesn't matter what it is. You know, I can go with x, y, z, I can go with a, b, c, I can go with whatever I want. It doesn't change our rules. So if anyone's kind of like, well, I'm used to seeing h and k there, that's fine, but if I call it something different, that's okay too, right? Variables are just letters that represent numbers. The one thing that your book did not do last year is put numbers in front of the x variable. Okay, we didn't have a coefficient for that x. And so this year we want to go ahead and stick that in there. And so what I'm going to do is I'm going to change this just a little bit. This year we're going to say f of x, which means the same as y, all right? And that equals a times the quantity bx plus c squared plus a d value. All right? K and d are the exact same thing. They mean the same thing. They do the same thing. H and c, again, same thing. They affect the graph the exact same way. I'm just choosing a different letter than what our book last year chose. And so our goal now is to figure out what does A, B, C, and D do to that shape right there. How does it move it around the coordinate system? Does it make it a little bit wider or a little bit narrower? Things like that, okay? And so as we do each of these functions, what we want to do is we want to start with what's called the parent function. And the parent function is the most basic graph of a parabola. F of x equals x squared. Okay, same thing as if I said y equals x squared. And what does that graph look like? So to examine this, I'm going to go ahead and grab a grid here, an xy coordinate grid. Anytime you guys see me do this, if you want to pause the video real quick to draw your xy coordinate system, you can do that. I know it's always hard when the teacher keeps on talking and you're trying to draw your graph, but again, that's the beauty of the video, is you can pause it and get your picture set and then go from there. Okay. So normally when we graph this, this is like the very beginning. We would have made an xy table and we would have plugged some numbers in here. If I pick 0, 0 squared is 0. If I pick 1, 1 squared is 1. 2 squared would be 4. If I go in the negative direction, negative 1 squared, so a negative times a negative, that's positive. And 2, or negative 2, if I square that, I would get positive 4. So if I plot those points, I've got a point right here, 1, 1, and then 2, 4 would be right there. And usually what I do is I say, once I have one side of the parabola graphed, I know that I've got symmetry on the other side, so I could just kind of come over and put these dots on the other side, and there's my parabola. Now, I'm going to show you guys something new that isn't, it's not rocket science, but it might be something you've never thought of before. Whenever I graph a parabola, as soon as I know where the vertex is, I'm thinking to myself, however far I move away from the vertex, the distance I go up to find a point, so I'm going to call this n, okay? I'm going to move a certain number of units to the right of the vertex, and however many units I move over, I'm going to go up n squared. Because that's what a parabola is, we're squaring something, right? So you go over 1 unit, 1 squared is 1. You go over 2 units, 2 squared is 4. If I go 3 units over, I need to go up 9, okay? And it doesn't matter which direction with the parabola. If I go 3 units this way, I'm also going up 9 units, okay? And if I remember that, then really all I have to do is just find the vertex, and then I can plot 2 points on one side, symmetry on the other, and boom, I'm done. I've got my graph, okay? Now, the problem here is this A and this B value kind of mess with how far you really go up, okay? What we see right here is only true if A and B both equal 1, right? Then this works for everything. I just got to find the vertex, draw the graph. So what happens if A and B don't equal 1? Okay, that's something we're going to have to figure out today. I'm going to put that on hold for just a bit because we're kind of tackling the most difficult idea as opposed to working with the easy stuff first. Okay, so we're going to come back to that. One thing we want to know is what happens if A is negative? What does that do to the graph? And you guys should know the answer to this. You think in your head right now. It flips the graph over, right? So if A was a negative 1, this whole thing just flips across the x-axis. And so what I'm going to do here is every time we develop a new function, whether it's a square root or an absolute value or whatever, we're going to come back and list some rules here, okay? So if A is less than 0, that means A would be negative, right? Then our parabola opens down. We'll just draw that with a picture. Okay? If A is greater than 0, if A is a positive number, it opens up. If A is a negative number, then it opens down. Okay? What if B is a negative number? Right? What if I have a negative 2 in front of this x? How does that affect the way the parabola looks? Well, again, the beauty of this is the rules will be the same for every function we graph. But in a parabola, what happens is if B is negative, it flips the parabola over, but because we have symmetry, it really doesn't look any different. Right? So in this case right now, we're basically saying if B is negative, it doesn't affect the way this graph looks. It still looks the same. In reality, it takes this curve and it flips it across the y-axis. This piece goes over here, this piece goes over here, but it still looks the same. Okay? All right, so this is our parent function, which means every time we graph something, if I put in numbers for A, B, C, and D, it's going to look like this. It's just going to move around the coordinate system to different locations. It might get a little wider, a little narrower, but it's got to look like the parent function. Okay? So, one of the things I said to you guys was, if I know where the vertex is, then it's pretty easy to find a couple points. So the vertex is always at negative c over b, comma d. Okay? And one thing that'll happen is, as we go through and graph different functions, I will keep on asking you guys, hey, there's this one point that's really important. Where is it located? And it's always the same. It's always negative c over b, comma d. It means we're taking the opposite of this value, divided by whatever b is, that's my x-coordinate, comma d. I don't do the opposite here. Okay? And if I can find that vertex, then I can just say, okay, however far you move over, go up that distance squared, and you've got additional points on your parabola. So now the question is, how does this a and b value affect what's normal? I call this a normal parabola. It matches the parent function. If I go 4 units over, 4 squared is 16, I got to go up 16 units to get to another point. That's normal. Okay? But if I stick some other numbers in here, they're going to affect what's normal. I might have to go up twice as far as what's normal, or half as much as what's normal, or a fourth, something like that. What we try and do is we try to keep those numbers fairly easy to work with. I don't want someone to have to go up 32.5 times as far as what's normal. That's not easy to work with. Okay? But what we're going to say is we're going to multiply this distance. Okay? So if I go over 3 units, 3 squared is 9. I'd normally go up 9. But I'm going to do a times b squared times as much as what's normal. Let's say a is 2 and b is 1/2. So I would do 2 times 1/2 squared. A half times a half would be a fourth. 2 times a fourth would be 2/4, which reduces down to a half. It would mean that I need to do half as much as what's normal. So if I went 3 units over and 3 squared is 9, instead of going up 9 units, I'm going to do half of that. I'm only going to go up 4.5 units, okay? Now, I know that as I say all this stuff, in your head you're kind of going, oh gosh, this doesn't even make sense. As we start doing examples, this will make sense to you guys, all right? So, here's what we know. We know what a parabola looks like. Every time I see that exponent of 2, I'm thinking this. I know whether it opens up or down. I know how to find the vertex. And from there, I just need to find some additional points based on what we see here. So let's do an example. Let's say I've got f of x equals 2 times x minus 1 squared plus 3. Now, I decided not to put a b value in there for the first one because it makes it a little more complicated. But the number in front of x right now is understood to be a 1. Okay? So, what I need to do is I need to first of all think to myself, does this parabola open up or down? A is positive, so it opens up. I need to know where the vertex is. So the vertex is at negative c over b. So negative c means opposite of c. So a positive 1 divided by 1, that's 1, comma 3. We don't ever change that to the opposite. Okay? So I know it opens up, I know what it looks like. Because this a value, so see, I'm always going to write this down, a times b squared. Now, if anybody looks at this and you go, how am I going to remember that? Well, it's right here, ab squared. If this was a cubic function where that exponent's a 2, well, then I'm going to go ab cubed. If this is a square root function, I'm going to go a times the square root of b, okay? So you'll know what to do because it's written there. So this equals 2 times 1 squared. Remember, order of operations, you got to do the exponent first. So that's 1 times 2. I get 2. This means I'm going to do twice as much as normal. So now I just need to get an xy coordinate system and draw a picture of what this graph would look like. All right, so first thing I need to do is I need to put my vertex on the graph, 1, 3, right there. I know the parabola opens up, and I know I need to do twice as much as what's normal. So if I start at this vertex and I go over 1 unit, 1 squared is 1, but I need to go twice as far, I need to actually go 2 units up. If I go over 2 units, 2 squared is 4. See, I'm no longer looking at this equation. I'm just thinking, what does a parabola normally do? If I go 2 units over, 2 squared is 4, so I'm going to go up 4 units, but I have to go twice as far. I got to go up 8 units. Well, that's going to take me all the way off the graph. It's going to be way up here somewhere. So what I'm going to do is I'm just going to say, you know what, there's the points that fit. There's my parabola. Now sometimes people would say, well, I need to show that it goes up 8 units, so I'm going to change the scale on this and count by 2s. There's nothing wrong with that, but I would say don't ever change the scale unless you really have to. Okay? Like if my vertex was way up here and I'm opening up, there's really no more points, maybe then I want to change the scale. But I'm not going to change it unless I really have to. There's my parabola. I'm good with that. So again, I'm trying to keep these first couple on the easy side. So I do have a negative a value, but both a and b are 1s, so they're not going to affect the parabola in terms of what's normal. It'll just be a normal parabola, we just got to get everything in the right spot. You guys go ahead and try it. Alright, so right away I see we got a negative sign out in front, so this parabola opens down. I know that the vertex is going to be at opposite of this divided by 1, so that's 2, 3. Let me grab a coordinate system. It's just a normal parabola. A lot of times I'll even write that word normal, which means it looks just like the parent function. If this is the vertex, however far I move away, I've got to go down that distance squared. And however far I go this way, same thing. Okay? So 2, 3. There's the vertex. It opens down. And so it doesn't matter which side you work on. If I go over 1 unit, 1 squared is 1. If I go over 2 units, 2 squared is 4. So I'm going to go down 1, 2, 3, 4. Now let me make sure we get this. When I go 2 units over from the vertex, I have to go down that distance squared from where that tip of the arrow's at. Okay, it actually should be a little bit lower on this point right here, but I'm going to go down 1, 2, 3, 4. Okay? So we'll make sure we get that. Sometimes people think they're going down from the vertex. No, it's however far you moved away from it. If I go 3 units over, 1, 2, 3, now I have to go down, 3 squared is 9, so I got to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. And it does fit, so I can put that on there. Now, do you have to get that point down there? No. I think if you get 2 points on each side, you're doing fine. The previous problem, we couldn't because it went off the grid, and we could only get 1 point on each side. All right, so now I know that parabolas have symmetry, so there's going to be a point here, there's going to be a point there, and there's going to be one right there. Symmetry means it's the same on both sides. And here's my parabola. Now, you know, I don't get real picky about artwork, but I do get a little picky about some things. Like, if you completely miss a point, you should fix that, all right? Sometimes you can fix it by just making the point larger. So like if I would have missed this point right here, I would have just gone back and made the point larger so that it looks like the graph is hitting that. But we don't want to put, what do we have here, 5 points? I don't want to put those 5 points down and then not hit them. You know, then I made a mistake in drawing. But do I have to have the perfect curve in here? No. It's just draw the best graph you can. All right, let's do another one with some A and B values. All right, you guys go ahead and try and draw this. I want you to draw a picture of what this graph would look like. All right, so again, you know, it's a parabola, so I'm just going to draw a picture of what I want to see on my graph. It opens up because that's positive. My vertex is at -1, -2. And I've got 1/2 times 1 squared. 1 squared is 1 times 1/2. That means we're doing half of, I'm just going to say of the norm. Okay, half of what's normal. All right, so we know it opens up, we know where the vertex is, we know we're doing half of what's normal. And so -1, -2, there's my vertex. It opens up. So normally if I went 1 unit over, I'd go up 1 squared, which is 1, but I'm going to do half of that distance. If I go 2 units over, 2 squared is 4, but I'm going to do half as much, I'll only go up 2. And if I go 1, 2, 3 units over, then from this point right here I need to go up 9, but half of that is 4.5. So 1, 2, 3, 4 and a half. And I think that's plenty to see what this graph looks like. So we'll get symmetry on the other side. And there's that parabola. So what we see happening is when this number gets smaller, what it actually does is it takes your parabola and makes it wider. If this number was larger, it means my y values are going up faster, and so the parabola gets narrower. Okay? So now we have the tough question. So this is in general form. All right? General form looks like this. Y equals ax squared plus bx plus c. What I want to do is I want to get my equation into vertex form. So vertex form is this. Y equals a times bx plus c squared plus a d value. Now, why do I want it in vertex form? Because it's very easy to figure out where the vertex is. It's very easy to figure out if it opens up or down. And then I just got to draw the picture. Okay? And pay attention to, is this more or less than what's normal? Okay? General form, I know it's a parabola. I know it opens up if this is positive, down if a is negative, but I really don't know anything else other than that. Now, really important to understand something. These a, b, and c values are not the same as the a, b, and c values down here. It's not just a straight transfer, okay? We're going to have to figure out what they are. Usually the a values are the same, but that's it. That's the only one, okay? So what I want to do is I want to get this equation to look like this so that I can graph it in vertex form. By the way, just so you guys know this, our book calls this standard form, which is kind of weird. I thought, no, this is vertex form because you know the vertex. So I went and looked this up on the internet, what's standard form, and they actually showed this. So then I said, well, what's vertex form? And they showed this. And so it got a little confusing. Don't get confused by that. When I say the word vertex, to me that means I can look at it and easily see the vertex form. I can see the vertex of that parabola. All right? So I'm always refer to this as vertex form. All right, so how do I get there? Well, I'm going to take this equation and I'm going to write down the first two terms, but the third term I'm just going to kind of push off to the side a little bit. Okay? And what I want to do is I want to create something here that is a perfect square. Because if it's a perfect square, I can write it as something squared, right? And then it's in vertex form. And so we're going to do this process called completing the square. What I want to do is I want to take, so right now when I say b, I'm referring to this number in general form. I want to take half of b and square that and put that number right here. Okay? Now, this is supposed to be a b, not a 6, right? But b does equal 6, so I'm doing 6 divided by 2. That's 3. Square it, you get 9. And what I've done is I've just created something that I can factor, and both factors are the same. That's why we call it completing the square. Okay? But we all know, Judson, you can't just go write a number in there, you just change the problem, right? Yeah, you're right, I did. So what I'm going to do is, if I add 9 right here, I'm going to subtract 9 out here, because those two things added together equals 0. And so what I really just did is I added 0 to this equation. Now I haven't changed it, right? 0 plus anything is the same thing. But it's going to look a little different. So I'm going to factor this so that I get x times x. What two numbers do you multiply to get 9 and add to get 6? Got to be 3 and 3. And that makes sense because I want those to both be the same. Out here I got 7 minus 9, that's -2. And so now my equation is this. X plus 3 squared minus 2. Now I'm ready to graph this, okay? So when I see something that's in general form, that's not as easy to graph. I want to convert it to vertex form, and then it's easy to graph. Okay, you guys go ahead and try this. All right, so now I look at this and I see that my A value is positive, right? There's nothing there, so it's understood to be a 1. It's a positive 1, so my parabola opens up. The vertex is at -3, -2. And since A and B are both 1, that means this is a normal parabola. So now we can draw our picture. -3, -2, it's right there. It opens up. So if I go 1 unit over, 1 squared is 1. 2 units over, 2 squared is 4. 1, 2, 3, 4. 3 units over, I have to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're starting to go off the graph. It's close enough I can put it in there if I want, but I don't have to. There's my symmetry. Okay, I hit all the points, and I'm off by a little bit here, so I'll just make it bigger. And there we go. I've graphed that parabola. Let me give you guys another one to try. All right, so we want to first of all convert this to vertex form. I'm gonna help you guys get started with this, and then I'll let you finish it up. But this one's a little different because we have a 2 out here where our A value is. We didn't have that in the last problem. So how do we get through that? Well, I'm still going to do the same thing. I'm going to separate these two terms from the 3. So I've got 2x squared plus 8x. I'll push this 3 out a little bit. And then what I want to do is I want to factor a 2 out of each of these. So when we're doing this process, it's called completing the square. The only way you can do it is if you've got an x squared term by itself. So whatever's in front of that, I have to be able to factor it out. Otherwise, we're going to run into trouble. Okay? So now if I factor a 2 out of here, that's going to be 4x. I'm going to add a number in here that allows me to make this into a perfect square. And I only factored a 2 out of these two terms, not the 3. Okay? It's not inside the parentheses. So now we can go ahead and complete the square and try and convert this into vertex form. You guys see if you can get it to vertex form. Alright, so to do this, I want to take half of this number, which is 2. I want to square that and add it right here. Alright, so 2 squared is 4. That means I want to add 4 to that spot, which means I should, we gotta be careful here. I know we're all thinking we should subtract 4 out here, but when you come back and look at this, if I distribute this 2, this really becomes 8. And so I didn't really just add 4 to the problem, I really just added 8 to the problem. So you gotta be a little careful there, that's tricky. So I need to subtract 8 out here. Now I can get this into vertex form. I've got 2 times, I'm going to factor this, so this would be x times x, 2 numbers you multiply to get 4 and add to get 4. Got to be 2 and 2, both positive. And this will equal a negative 5. And so now my function in vertex form is 2 times x plus 2 squared minus 5. You guys go ahead and see if you can finish this up and graph it. All right, so when I take a quick look at this, my a value is positive, so I know the parabola opens up. My vertex is going to be at negative 2 comma negative 5. And if I do a times b squared, my a value is 2, my b value is 1. So that's 2 times 1 squared, which is just 1 times 2, that's 2. So I want to do twice as much as what's normal. All right, so vertex, negative 2 comma negative 5. Parabola opens up. So if I go 1 unit over, 1 squared is 1, but I need to go twice as far. If I go 2 units over, 2 squared is 4. 1, 2, 3, 4. But I need to go twice as far. So another 1, 2, 3, 4. And then I've got symmetry on the other side. And now I can draw the parabola. All right? So again, notice as this number gets larger than 1, because the y values go up faster, it makes the parabola appear to get narrower. And if that value is less than 1, like a half, well then the y values don't go up as fast, so it appears to get a little bit wider. All right, so we have one last thing to do. We need to add 2 functions here, not just one. We've done the parabola. Now what we need to do is we need to do the absolute value function. Now the good news is, if you get the parabola, then an absolute value is a piece of cake. We can do this really fast. So we're going to kind of go through this procedure again with the absolute value function. But I think now understanding the parabola, this goes really fast. It's really not bad. So an absolute value function would look like this. F of x equals a times the absolute value of bx plus c plus the d value. Now again, last year you guys had h and k, but those are just variables. We can call it whatever we want, okay? I'm always going to use a, b, c, and d because then our rules are always the same for all of these. So the first thing we did with the parabola is we said, let's go look at the parent function, the most basic absolute value function. Y equals the absolute value of x. So I'm going to do the same thing I did before. I'm going to make an xy table. I'm going to plug some numbers in. I'm going to go negative 2, negative 1, 0, 1, 2. So the definition of an absolute value is, it means how far is this number from 0. And because we're saying how far, that's a distance, and distances are always positive. I can't travel a negative distance. I can say I'm walking backwards, but I'm still a certain distance from where I was, right? So that's all that means is just, plug the number in and make it positive. It's a distance from 0. So negative 2, how far is that from 0? 2 units away. How far is negative 1 from 0? 1 unit away. How far away is 0? 0. And then if I go to the right, 1 unit from 0, that's 1. 2. How far is that from 0? That's 2. So now if I plot those points, I've got -2, comma 2. So -2, comma 2. -1, comma 1, right there. 0, comma 0. And then 1, comma 1. And then 2, comma 2. And so you can see that what we have here is a V-shaped graph. Okay? Looks like the letter V. And these are straight lines. There's no curve in this graph. It's just the letter V. And this point right here is called a vertex, just like in the parabola. So I told you guys I was going to do this. Every time we graph something new, there's going to be an important point that we talk about. And I'm going to ask you, how do I find that? And the answer is always the same. So where is the vertex? You should be thinking in your head right now. The vertex is at -c over b, comma d. Exactly the same as the parabola. I'm going to do the opposite of this, divided by this, comma whatever that number is. Okay? If a is negative, so less than 0, then my absolute value would open down, just like the parabola. And if a is greater than 0, so it's positive, well then it opens up. We don't say, well, what happens if a is 0, because 0 times anything is nothing, the absolute value function's gone. So we're not going to see that happen. Okay? Guess what I would have is just f of x equals whatever this number is, and then that's just like saying y equals 3 is a horizontal line. All right? So the only other thing we really need to know is how steep are these lines? I mean, if they're lines, they should have a slope associated with them. All right? And so as it turns out, the slope of these two lines is going to equal plus or minus. Now, the reason we say plus or minus is this is a negative slope because it's going down as you go left to right. This is a positive slope. It's going up as you go left to right. So there's always going to be one positive and one negative. Okay? And to get that slope, it's just a times b. Whatever these two numbers are, you just multiply them, and that's it. I've got my graph. So slope equals plus or minus a times b. All right, let's do a sample problem. All right, so I'm going to graph y equals 1/2 times the absolute value of 3x minus 6 plus 1. So I'm just going to list my basic information to start with. A is positive, so I know this absolute value function opens up. My slope is going to be plus or minus 1/2 times 3. Now we've talked about this already. When you multiply an integer times a fraction, you just multiply it straight into the numerator. Right? Because as a fraction, this is 3 over 1. So I multiply 3 times 1 and 1 times 2. And so what I really get here is plus or minus 3/2. Okay? Rise over run. Up 3 over 2. This is a case where fractions aren't scary. The vertex is going to be at opposite of this divided by this. So a positive 6 over 3, comma 1. Or, what is that, 2 comma 1. That's all I need to graph this. So let me just pull in a grid here. So the vertex is at 2 comma 1, that's right here. I know it opens up, and my slope is 3/2. So what I'm going to do is, from this point right here, from the vertex, I'm going to go up 1, 2, 3, and over 2. Then go up 1, 2, 3, and backwards 2. Now, could I do an additional set of points? Sure, I can go up 1, 2, 3 again and over 2. Do the same thing here. From this point up 1, 2, 3 and over 2. And then I could have another set of points. But I think I've got enough there to see what this graph looks like, and so I think we're fine. That wasn't too bad, right? There is no twice as much as normal or half as much as normal. We don't do that with the absolute value function because all I need to know is what's the slope of those two lines. And I've got what I'm looking for. Let me give you guys one to try. All right, so remember, we're pushing everything a little bit farther in here. So we see those fractions and we go, oh, you know. But the rules don't change, you know. This should not be bad for us, all right? So which direction is it open? Where's the vertex? And what's the slope? You guys go ahead and try. All right, so I know it opens down. When I find the vertex, I'm going to do opposite of this divided by this. So a -1 divided by 1/2, comma 4. To divide by a fraction, you got to flip it over and multiply, so that's really just going to be a -1 times 2. So the vertex is at -2 comma 4. And our slope is going to be plus or minus 5/2 times 1/2. I don't even care about the negative sign here because I already know one's positive and one's negative. All right? And I know that that negative sign is making this thing open down, so I really don't care about it at this point. I'm just going to multiply here and get 5/4. So here's my graph. My vertex is at -2 comma 4. 1, 2, 3, 4. I know this thing opens down, and so rise over run, it's 5/4, so I've got to go down 1, 2, 3, 4, 5, and over 1, 2, 3, 4. I'll go down 5, and then I'll go this way, 1, 2, 3, 4. There it is. I have graphed that absolute value. These are way easier than the parabolas. I think if we understand the parabola, this is pretty easy. All right, that's what I have for you guys for today. So our assignment is going to be a little bit different. Because our book just assumes that we know this stuff and they just kind of plow right through, I need to kind of branch off and do something different. So what I'm going to do is I'm going to have like a little worksheet each day that these are the functions that we're going to graph. These are, I'm going to give you 10. These are the 10 functions we want to be able to graph. And I'll put them up here in a second, and you guys can just like snap a picture of it with your phone. All right, so here's the equations that we want to be able to graph. I've kind of mixed parabolas and absolute value functions in here together. I've got some that require us to complete the square and some that don't. Fractions are a little bit harder for me to make, so when you see 0.5, I would just write that as 1/2, okay? Or, let's see, do I have anything else? I think that's all I have in here is 0.5s. I would just write it as 1/2, okay? Now, the other thing that I want to say to you guys is, since we're graphing things right now, it would be nice to have graph paper to do this on. And so if you go to my Sway page, classroom website, and let's just go down here to where it says graph paper. So right below pre-calculus, here's graph paper, and right here we get 6 graphs on 1 page. These are the same graphs that I use when I'm dragging something out on the smartboard here and trying to draw a picture. So you guys can print this out, and then you can just write your equation up there, write down the information, where's the vertex, which direction is it open, what's the slope, things like that, and draw a picture. And then take a picture of that, and you can turn that in for your homework, okay? I think that's the easiest way to do this. If you did 1 page front and back, that's 12 graphs, that's enough for this assignment. Okay? This will always be on my Sway page, you're always welcome to use it. As long as you have a printer and paper and you can print this thing out, you've got graph paper available, okay? All right, that's it. Oh, one more thing. I'm going to, let me go back to this. I will also take these problems and put them on the Sway page, just like we had our first day orientation, we had the New York condo and the Walmart and basketball. I'll add a link here that says, you know, here's our parabola and absolute value functions for graphing. So if you don't want to leave it open, or let's say it's just hard to view it that way on the video, you can come here and just print it out as well. Okay? So there'll be an additional link here after you guys watch the video. All right, so that's it. You can take a picture with your cell phone or just get it off the classroom website. All right, you guys, have a good weekend. I'll see you on Monday and Tuesday. Take care. Be safe.